Welcome to Trends with Benefits, an award-winning podcast by Van Eck with a forward-looking perspective. We explore new ways of thinking about the markets, work, and life. Here's your host, Ed Lopez.
Well, I figured we'd talk about something very close to your heart, which is robots. A lot to talk about these days. But maybe just before we even get going, there's a few headlines that caught my attention recently. Just maybe more for fun. One, I noted that Uber is using delivery robots. I don't know if you've followed that at all recently. They've expanded their program in California. I don't know. Do you know anything about that? What do you think about that?
Well, I think it's a natural step, right? We have Uber Eats, and it's been, my understanding is a very successful business. In dense populated environments, it does seem on sort of the area of expertise of Uber on switching to autonomous cars. Just a few years back, and they hired, put a lot of money. They run semi-successfully trials in Arizona that as far as they remember, and at a certain point they had an accident and that kind of kill a program. But they gather the expertise and they know how to do it very well. Now, I need to go in and sort of the details on exactly what type of systems they're using, but it is a safer bet to use just smaller type of machines that they do delivery kind of door to door, or from restaurants to homes and hotels, and that's a much lower risk sort of type of business. In that you're not, driving a 3-ton vehicle and do this kind of accident. So it makes a lot of sense.
Yeah, it's really fascinating, and in particular that they're expanding that program. One of the other headlines that crossed my newsfeed, which I thought was interesting, was a headline about an Air Force program or AI drone that attacked its operator. It turned out to be false, but I feel like we are so close to that. Not possibly happening, making that plausible. And it raises questions of people think about Terminator and Skynet and all of that from the old movies and stuff. I don't know. Is it plausible? Are we at that point where AI could drive, drones to have, I don't know, their own mind?
Well, so certainly there is strong efforts, and one of my funding agencies in my laboratory is the Air Force. We do have programs of the type that you're talking about. There is an increased demand of autonomy, but often and with the concept of trustworthiness is becoming more and more important. The concepts related to ethics are more important, and there is an ongoing discussion that not only outside but within the Air Force and the companies that are catering, the Lockheed Martins and other companies, Mitre Corporation, and so on, that is constantly ongoing. So definitely it's on their radar, and at the center of their radar, and all of that. Trustworthiness is very important. Safety assurance, what is called safety assurance, is very important as well. And often this comes in the ability of involving operators in some capacity. Of course, having autonomy promises to have sort of more coverage, more capability, better reconnaissance, which is fundamental for some of the engagements they do. And also it has the civilian counterpart of it, which is the area of search and rescue, SAR, and the area of disaster response, fire mitigation, and Air Force and other partners are very much involved in those. So it has these two sides, right? In one hand, how combat in the future is going to be fought. We already see, obviously, in Ukraine, a great use, the number and the scale of drones. That's going to happen more and more, and autonomy is going to become more and more important. And then we have the sort of the flip side of that, which is the civilian search and rescue and disaster response, fire mitigation, which is very important. The things seem to be moving towards the area of what we call human-machine teaming or human autonomy teaming, in that there is an operator, and the operator is normally involved in the visualization and the interaction with not one unit, but many units, as many as possible. So areas of what we call cognitive workload, the ability of a person to monitor many devices, the APIs, the reaction times, the trust that these operators put on the systems, and the exchange of information in general is becoming sort of central to these operations. So I can give you a few examples, but I want to stop here and get more questions from you.
Yeah, we'll definitely get into more of that. And, I think one of the areas that you focus on is that human and robot interactions. And I definitely want to talk about that. But let me do a more formal introduction, which I've failed to do so far. But I'm speaking with, I don't know, is it all right to call you a roboticist? That's fair, right?
Absolutely. Yeah. That's a name you can have for me.
Speaking with Luis Sentis, a roboticist, but he's also an associate professor at aerospace at University of Texas in aerospace and mechanical engineering. He's co-founded Apptronik Systems in Austin, Texas. And he leads the human-centered robotics laboratory at UT as well, involved in a lot of different areas. So I'm really excited to speak with you. And again, thank you for your time this morning.
It's a pleasure, Ed. Thanks for having me here.
When I started thinking about robots and started thinking about AI and artificial intelligence, what seemed to kind of burst onto the scene this year, even though there's been a lot of work behind it, it made me think about what robots really are. In your mind, what are they mechanical beings? Are they software? Combination of both?
Well, it's a very good question. I found myself responding to a similar question just a few weeks ago with another journalist, and there's no consensus of what, there is no sort of scientific definition of what a robot is. I think what is, widely accepted is that robots are trying to mimic some of the physical abilities of and cognitive abilities of us human counterparts, and those really can come in many, many forms. We are very used to see robotic arms, and that perhaps is one of the first examples of our modern conception of robotic systems. When we think about fingers, arms are already very anthropomorphic. It has been more recently used as more in the cognitive and the computational part of deployment, and those are the bots that we see, whether it's internet crawlers, and then of course the LLMs and so on of today might be considered robots, but those are sort of more of a twisting, moving the embodiment part of a robot. I do personally prefer to see robots having a physical embodiment.
In terms of artificial intelligence, am I right? Does it seem like it's just really burst onto the scene this year? And have you had a lot of interaction with that or using that in your systems? What do you think has really spurred that on this year in particular?
Well, there's been breakthroughs in deep learning for quite a while. In computer vision since 2009, we've had the ability of recognizing more and more our environment, semantically labeling, putting names to things, and there have been dramatic improvements on things that are perhaps less obvious to robotics, localization and mapping and knowing where you are in your environment. There has been also economies of scale kicking in robotics, in particular the price per component, to the point that you can purchase now very sophisticated robotic systems for just a few thousands of dollars. And those are not hobbies, kind of Lego types kind of systems. We're talking about fully capable robots of navigating an environment and manipulating an environment for prices that was not affordable today. The confluence of all of these together is making a big splash. And then one of the arguments I make particularly in the US, and I've been in the mid-1990s, I worked in Silicon Valley in automation and robotics, and then I went to work school, and I went to an academic career. I found a company, so I've been back and forth with seeing sort of the markets here in the US. And what is new is that e-commerce has exploded more than it had before, and it has embraced robotics fully. And that's where we're seeing the most growth, right? First of all, being led by Amazon, obviously, and Amazon, the array of robotic systems that they have inside, the ones we know and ones that we don't know, is just phenomenal. But there is suddenly the appearance of the robotics unicorns, which didn't exist before. And we have now companies like Dexterity, companies like Covariant, Plus One Robotics, and Intrinsic by Google, and so on and so forth. All of them are unicorns. And that's it. And those are robots that they are performing what we call simulation tasks, which means moving boxes. And this is very unique to this moment. It was not, this industry was not there before. People are making money. Suddenly there are roboticists. You know, you would Google 10 years ago. I'm a robotics student. I want to find a position as a roboticist. Well, there was no roboticist positions. You will find, you know, whatever, controls engineer or just engineer, mechanical, electronics, software, and so on, but not robot. Now it does exist, and there is a new sort of path towards fulfilling those new positions. So the confluence of all of that, and we can talk more about the AIs, their new capabilities, is making this an economically viable direction, and is making industry very successful. And is making the academia and the studies associated with robotics becoming very relevant for the times.
What do you think is the most important component in a robot? Is it the semiconductors? Is it memory? Or something else?
It's a good question. So I don't think you can point to a particular piece of it. The actuator is sort of the equivalent to our muscles. And, you know, if you would say, if you would ask what is the most important part of a human, people would probably point to the brain first, and maybe, certainly the heart would be second, maybe the muscles would be third. In the case of a robot, there is not real heart. There is nothing pumping, so that's removed. The brains only recently have started becoming a thing, and is certainly starting to become the most important component. But I would say in the mechanical sense, the actuators, what is called the actuators, is the most important part of it. And those are the electromagnetic systems, the motors that they turn, and then coupled with a gear, are providing all of the movement and all of the forces as well. And all of the safety as well, and perhaps this is making them even more important, because now we're requiring the systems not only to operate a sort of, cage robots on the side, but now we're requiring to be operating right next to a human. So all of this mechanical intelligence at the motion level, at the force and safety level, they are contained in this single component called the actuator, which contains the motor, it contains the gear, it contains some of the transmission as well.
And that's what you spend a lot of your time on and a lot of your research on. Is that right? Is that particularly, I think, what you're probably well known for is the robot that you worked on with NASA?
Valkyrie, yes.
Valkyrie,
well, thanks for saying that, Ed. Indeed, we early on when the lab, the Human Centered Robotics Lab here at the University of Texas, 14 years ago, was set up. We made our direction that we'll build robots from scratch. We'll investigate new type of embodiments, and we really didn't know what was the interest, and we started building actuators. You cannot ask a small business or a student, as a matter of fact, to build a humanoid as their master thesis, right? But you can ask them to build very sophisticated actuators. So we put our bet on the actuator, which we thought it was something that was the area of mechanical speaking was exhausted and was already investigated in all possible forms. Notoriously, MIT had developed something called the Cirrus elastic actuator back in maybe the late 1980s. It had become very popular in academic and NASA environments. Robonaut had used extensively. Robonaut from NASA is one of the upper torsos that flew to International Space Station. So it had used Cirrus elastic actuators before we enter the game. But then we put the bets on developing a new iteration over Cirrus elastic actuators. And those was a clever mechanical design that we had reversed, something called the ball nut and the ball screw, and we had a piston-like drive. It was a very clever, compact sort of design that allowed these actuators to go from like a foot and a half long to being a half a foot long with the same power density. And then NASA became very, very interested and invested very heavily in my lab in the early 2010s, and that made up portions of Valkyrie. And so we were able to sort of innovate that on that front, and new versions of these actuators, liquid cooling in particular, that we iterated on. It piqued the interest of the Navy. And the Navy invested also heavily in my lab, and later on in Apptronik, a company that we spin off. And Apptronik is now based on these sort of IPs and discoveries in actuators, because really it was an actuator company to start with. Now is a systems company, it's a humanoid systems company. Now Apptronik has 90 employees. It has heavy investment, and always thanks to this. You ask what is the most important piece? Well, all thanks to the actuator, right?
Yeah.
Of course, you make up the system with that component. But
that's awesome. Are you still working with NASA or doing consulting with them?
I want to say yes. So I was engaged with NASA on a sort of regular basis until before the pandemic, and then the lead of the NASA project, Rob Ambrose, fantastic guy. He left NASA and then he joined Texas A&M as a faculty, and in the area of aerospace systems. So we continue being engaged with Rob. So sometimes you follow wherever NASA goes. And Apptronik it just finished building Valkyrie 2. NASA went through another iteration of Valkyrie, and then the contract was given to Apptronik. So these are the two capacities that I'm engaged with NASA or former NASA personnel. The Valkyrie 2 has not been unveiled yet, but is already finished. The prototype is already walking and is already manipulating. And I'm guessing that it's going to be very soon where we're going to see Valkyrie 2s produced. I don't know what kind of numbers and what kind of capacity, but where NASA wants to take them to the next level.
What is their plan for it? Is it going to go on space missions?
So I believe that Valkyrie 2 is still going to be earthbound and is going to be sort of operating in analog setups. The grand vision of Johnson Space Center, which is really the sort of human operations, is to land in Mars, to land in the moon, to land in moons of other planets as well, and be able to land human astronauts. But before human astronauts land, we need to land robots, and these robots, they need to be able to set up an entire operation, entire habitats, entire energy supplies, and maintain them over time. So that's the objective of these very in a way, the way we see humanoids, we call them general purpose robots. It's not a robot that is specialized to a particular type of task, but just like you and I, that we are magically able to, make coffee in the morning, repair our door, take care of our garden, write on an iPad, type on the computer, just with our embodiment, move boxes and so on, right? We are fantastic, versatile, physical and cognitive machines. The same is expected from humanoids, and that's what humanoids are for. These general purpose systems and in the space are supposed to maintain both inside the habitats, so it's being sort of the constant kind of repair handyman that you have in these places that need to be clean, but also outside where you are deprived of oxygen. So it's much more costly to have an astronaut in a suit that is, thermally capable and has to provide all the life support. That's much more expensive than having humanoids outside. They're already equipped and they don't need this kind of life support systems outside. NASA is betting on this is going to be much more economic.
Tell me a little bit about Apptronik. I mean, you guys are also doing exoskeletons, as you mentioned, I think, in humanoid form. What is the area of focus there? I'd be curious in terms of what market opportunity Apptronik sees.
So, very good question. And the two areas where Apptronik is succeeding quite a bit, I want to say first in construction, and that's something that it has not been publicized, and the company is sort of keeping it a little bit on the private side. just because it's an emerging area, and they're having sort of a lot of success. So they're keeping it a little bit less public than we know of. But that's one of the principal areas of the company. Apptronik has an IP of very long arms, and at the beginning, the company had an ambition of competing on the sort of manufacturing arm that we see in all this industry. We talk about automotive and a clean room and processing and so on and so forth. But it turns out that the markets are incredibly saturated. There are maybe 1,000 different types of arms worldwide, including China and the whole world as a whole, right? That you can buy today in arms that they are about the size of a human arm. So it's nearly impossible to enter that business. So it occurred to Apptronik that some of the mechanical IP that also is part of the secret sauce, it cannot really be spoken publicly, but they have a particular IP that is essential for building very long arms. We're talking about 20, 30 feet long, and then being extremely lightweight, being 10 to 20 times lighter than some of the big, let's say, ABV or Fanuc arms that they are now handling a lot of the automotive sort of parts. The weight of the arm with respect to the payload is 1-to-1. You're lifting 200 pounds. The arm is, despite being 20 feet long, it still weighs 200 pounds. And that found, and not only that, but this IP also allows workers to be next to these gigantic arms. Matter of fact, they can push them, and the arms moves, what is called compliance, right? So you can grab it and then move it with your hand as if it was a very sort of lightweight system, right? These at this size, at this scale, is one of the areas where Apptronik is being more successful. And the funding, the investments that is coming are coming from large, part of the investment from large companies in construction, where they are craving for more vision-based AI and that into construction equipment. That's half of it. The other half comes indeed in the humanoid area, and humanoid is a discussion we've had at Apptronik many times. Sometimes we've been worried about the area being sort of niche and so on and so forth. But as you can see, this year has been a fantastic year for humanoids with Tesla figures, Chinese companies. There's going to be announcements soon that Chinese companies are developing humanoids for price points below 50K, entire humanoids. And so there is a potential there, and the same e-commerce companies that are investing into sort of truck loading robots are also interested in humanoids, and that's where the second business where Apptronik is making money and is getting investment, and also is spinning it off the sister area of that, which is the dual arm avatars that can be teleoperated. And now can, in retail business and so on, can also fulfill a lot of these tasks.
Yeah, that's fascinating. As you speak, I keep thinking about the implications for the economy, implications for labor, which I know is also an important area of interest for you as well, making sure that we as a society get that right. But just in terms of the leverage that I think robots of the future will have in our economy, I think it could be fascinating. In particular, I was on a call this morning with some of our portfolio managers, and they're portfolio managers in the natural resources mining realm, and one of our portfolio managers said something to me to the group that was just fascinating to think about. There have only been maybe 100 graduates of mining engineers around the world. It's so few that there's very few going into that labor pool. It seems like a ripe area for automation in mining. But I know there's other areas where we could see robots at play as well.
Yeah, and my mining industry, I don't know if you communicated before, there is a large the largest research organization in Australia, CSIRO, is notoriously famous for pioneering a lot of the mining robots for the last 30 years or so. In Brisbane, they have over Australia, they have a very strong group, which we happen to collaborate with. And they have a subgroup there called Data 61. More recently, they make news because of the DARPA subterranean challenge. And at the DARPA Subterranean Challenge, we saw cutting-edge technology and breakthroughs of a magnitude that we couldn't imagine before, of navigation and these very navigation and sort of operations in these very harsh environments. And Data 61 from CSIRO in Australia was one of the leading teams in this area. So definitely the same applies here, right? Is oil and gas and mining are areas that are dangerous. A lot of manual, forceful labor, and those are areas where also robotics is widely used. Now the scale of the business, I don't have data points of what machinery companies, what kind of monies they're making, with the Silicon Valley supporting those, but definitely something to contemplate and see. We expect to see a growth.
And with respect to robots entering the labor force, there's those that always raise the fear that they're going to be displaced. How would you address some of those fears?
So I do have an argument that I came up in the last few talks. So we do fear these events happening and the labor dynamics. But here's another counter argument, and then we have to be very careful. We have to cater our institutions to not allow large displacements and allow re-education. On the other hand, robotics promises is sort of a promised land of making things accessible to everyone. Transportation and manufacturing of goods and services, of housing, 3D printing houses, all sort of manufacturing of all sort of things that we need. And it turns out that we want to have things. Humans, and I'm making here an argument a little bit pro-consumption, right? That people have less of what they want, whether they are wealthy or not wealthy. Certainly the non-wealthy, they have much less things and services that they would like to have, and even the wealthier, they would like to have even more, right? So robotics promises to satisfy more of the wishes of people, a lot of the material and service wishes of people at all levels, and that's what it has to do, right? But also there is impediments. First of all, there's population dynamics that are occurring, and we see them very severe happening in parts of Europe and big parts of Asia, and here in the US. Not yet, right? But we're seeing populations of, let's say, Spain, which in 2100 will have half of the population of today, and Japan, China is going to lose 600 to 700 billion people in the next 60, 70 years, right? The infrastructure that needs to be maintained in those countries, certainly we're going to have a deep shortage of human labor. So we see a need for these systems. Here in the US, for instance, the VHA, the Veterans Affairs Hospital System, there are 9 million patients in that system, right? It's the largest hospital system in the United States. There is a deep shortage of personnel. There's a lack of nurses and doctors. Patients are not getting their meals when they need them. They're not going to the balcony to see the landscape when they want to. They're not getting fresh towels and so on. They're not getting the meds and so on, right? So it promises to cover these areas where there is shortages, and I prefer to see it that way. VA hospital system, we cannot afford at this moment having more personnel, right? So robotic systems is not substituting, is covering an area. Another area where I see that is not going to substitute existing labor, which I don't like when I see that, is on entrepreneurship and the small and medium enterprises, SMEs, right? A couple of young graduates get together and they have no money whatsoever. Let's say they want to start a business, let's say a brewery, and it suddenly becomes popular. There is demand. They have to deliver hundreds and thousands of beers and boxes per week, right? And well, there are 2 people. They cannot hire 16 people, right? So that's where I see robotics fulfilling this sort of multi-purpose or general-purpose robots fulfilling those demands. This reprogrammable machine that can do today packing and the next day pushing and the next day labeling and so on, right? And at a price point that is very affordable by these small businesses, I see them as enablers. That's what concept I wanted to say. So I think we have three cases, right? So we have a substitution that we don't like it. We have an augmentation that we like it in some cases. And then we have an enabling technology that otherwise these people with ideas, with dreams, they want to manufacture, they want to deliver, they want to transport, but they're young, they don't have the ability of raising those funds. Those machines is going to help them to run their businesses. And of course, the areas where we have a shortage of personnel in first place.
Do you fear that we as a society could get it wrong, maybe even just on the augmentation part, where maybe there would be a backlash? And has that driven some of your research in terms of human to robot interaction?
Sure. I mean, that has the two sides, the physical augmentation and the cognitive augmentation. Obviously, the LLMs are a form of cognitive augmentation. And I'm on the optimistic side of those conversations, that I do think, much in the same way that Wikipedia has helped us all to discover a vast amount of information and be smarter and more accurate, LLMs will push that to the next level. That's another conversation to have, and I'm sure your podcast is already interviewing people on that front. And then let's talk about physical augmentation, in particular exoskeletons, and which is a business we've been in for a while. Now is on hold. But in one hand, there is the ability of turning sort of workers into incredible machines that they can do tasks that otherwise would be impossible. And that is a desirable outcome, difficult to fulfill, but desirable. It has also the counterpart of the endurance to physical strain that we go through in our lifetimes. And what we're going to see is a lot of robotic systems, maybe exoskeleton, orthotic devices, but also chairs and furniture that is become robots as well. And their ergonomics are such that they have knowledge of our sort of physical fatigue. IT is one of the places that we're seeing that happening. You and I spend probably a lot of hours in our laptops, and we're seeing on the trapezoid muscles over here, frozen shoulders. We're seeing back pain to levels in the IT industry and IT related jobs that we have never seen before, and it's going to go higher and higher. It's going to have impediments in mobility. So we're going to see chairs becoming robots, and being aware of these very signals. So one of the things we're doing is collaborating with developers of new sensor modalities, what we call physiological sensing modalities, electrodermal sensors that measure stress, EMG, electromyography sensors that measure muscle activity, front lobe EEG sensors that look almost like hats, very simple, that they measure mental fatigue and so on. We're going to see them integrated with our sort of augmenting our physical structure, so we can perform the tasks that we do, IT and so on, in better ways. And then in the case of movers and construction workers, the same applies there. These devices promises to augment their forces, but also monitor their levels of physical fatigue, and then make sure that they don't get injured at any age, not at a young age, at any age whatsoever. I just wanted to finish this thought that there is this part of it, of at the muscle level, knowledge of the muscles, knowledge of the ergonomics, and furnitures and orthotic devices becoming more accessible to workers and to IT professions for just enduring this work. But there is also reports by places like OSHA and other safety agencies where we see how many accidents in the construction logistic business occurs per year. In particular, we have 500,000 accidents occurring per year of workers falling from scaffolding, from ramps, running into a machinery, these dangerous hydraulics, and all sorts of these work-related accidents happening. So we see also the need for these wearable systems to be informing people, and certainly VR, AR headsets, one of them, but also through haptic guidance, and being able to inform them about impending sort of dangerous, even being able to correct their movement slightly, and then reducing the number of accidents.
And yeah, is that where you see AI really playing a part too, being able to in sensors and things like that?
Well, that's right. I mean, so what happens? There's two things here. One is autonomy. Let's say that you have a machine that is telling you that you are going to run into a machine. You're not looking at it. Maybe you're too tired or whatever. It wants you to drive you to another area. It has to be smart enough to know that where to steer you to, or to suggest you to go to, right? And that means that benefits for all the advancements in deep learning, in particular reinforcement learning, the ability of simulating every possible scenario and then coming up with policies that solve every possible scenario. And on the other hand, we have what we call behavioral cloning and imitation learning. And then this is the ability of recording data from humans and of doing a similar task and vast amount of data. So we're seeing an increase on the databases that are produced by institutions and are offered, some of them for free, for training systems in order to know how to navigate in these environments. At the same time, we're seeing more of the AIs of sort of trying to understand the state of mind, the cognitive workloads, and the mental fatigue and the physical fatigue of humans. These two put together, autonomy and more knowledge of the physical sort of performance, will allow workers, particular physical workers, to be more healthy and safe.
So I'm going to ask you, maybe not so much for advice, and I'll throw out the disclosure, this is not investment advice necessarily, but just given your background and expertise in what you do, where would somebody like you go hunting for investments in this arena, like semiconductors, certain materials?
Well, there is more companies than you think of. You think of in the area of investing into robotics. For instance, a place called 11.2 Capital, Hilti Ventures. There's tons of them, and including some of the large companies, Meta, VCs, a lot of the CVCs, what we call CVCs, are investing, and there are some companies that they do have a stomach for investing in heavy duty robotic systems. Hilti is a large Swiss company, and they're investing in robots that do painting, for instance, and do some of the heavy duty sort of logistic tasks. And they're investing heavily. There is a company called JBot, the drill bot robots, another one called Canvas. They do drywall finishing. There is more and more construction investment. So there is 20, 30 VCs between Silicon Valley and some of the European countries that they will be very happy to invest in robotics. For those of you that listen to this podcast and you want to launch robotics companies, with proper search, you're gonna find them here in the U.S., in Israel, and in parts of Europe. You can launch a business. I promise.
So I've taken up a lot of your time already, so I should probably start to close it up a little bit. But one of the ways I close is asking my guest one question, which is, what's one long-term trend you see playing out over the next year or several years? It can be about robotics, or it can be about something else top of mind. What do you think?
Yeah, good point. Maybe a trend I see is robotics in the healthcare industry happening more and more, and transformation of hospitals into places that are they have more of the human touch, and perhaps that's something that and it's sort of weird to say it in the sense of robotics, but as we know now with LLMs, robots can now sort of. I mean, in a way, I don't see LLMs being robots, because they have learned from the whole human knowledge, right? So they are sort of the conglomeration, the amalgamation of all this body of knowledge. So they are us, right? It's like if you had a super big storage brain and you're able to read all the books in the world, and those are the books produced by humans. They're not learning from simulated books. They're learning from human books, right? So I see that. I see transformations on healthcare, on having more personalized, more human touch through these sort of devices, and I see also the machines themselves a trend where we're trying to anthropomorphize machines, in particular hospital machines. That we want them to look less like machines and more like things that we feel comfortable. Like we're talking to a chain of wellness centers, post-cancer treatment, that they are making an effort to turn the machines in things that they don't look like machines. For instance, the X-ray machines looks like an animal, looks like a giraffe. They are imagining transportation robots that look like bears and so on. And I think adding warmth of public spaces where robots are showing up in VA hospitals, not VA, but hospitals as a whole is one of the ideal places. So that's one of my favorite areas. We're obviously going to see more and more urban robots, what we call community robots giving tours of cities and portions of a city, museums, and so on and so forth. We're going to see more, obviously, delivery. We're going to see more personal safety escorts. We interview many students on campus here, and we were asking them what they would like a robot to be. And the majority of them is provide them safety, take them to the car at night. There is a number of grad students, they finish work at 1 a.m., 2 a.m., and they feel unsafe. They want to have, just yesterday I was in Boston, I ended up finishing a dinner late. I ended up crossing a dark park alone, late at night. There was nobody. And I would have loved to have a robot next to me that I had a direct connection to 911, to somebody watching over me. I see more providing safety and personal sort of services for people.
Well, I don't know if you've been to New York lately, but we definitely need those now. This is great. So, and the last way I close the podcast is with Trend or Fads, our speed round. You ready?
Yeah.
All right. Bitcoin, trend or fad? All right.
Totally.
E-scooters, trend or fad?
I think it's somewhere sort of hovering between both of them.
NVIDIA, trend or fad?
It all depends. There is a forum conversations about whether GPUs are gonna continue being the choice for everyone doing deep learning, and apparently it is contested whether it will last forever. So I would say right now a trend, but it could turn into a fad depending on an announcement that we're going to see soon.
Interesting. And then finally, space tourism, trend or fad?
I'm going to say fad.
All right. This is awesome. It was a great conversation. I really appreciate your time, Luis. What's the best way for people to follow you, maybe connect and learn about what you're up to these days?
We do have a YouTube channel called Human Centered Robotics Lab, HCRL. You can obviously follow through the company website, Apptronik.com. And finally, my lab, UT, has a website called sites.utexas.edu/HCRL that you can follow. Is in the form of a blog, and we have the latest, greatest over there. So we look forward to see your clicks.
Fantastic. Can I come for a tour?
Yes, please. Oh, yes, please. Come over. I'll take you for dinner. We'll give a tour. We'll give you a tour of the new robotics, Anahis Robotics building. We have 40,000 square feet. I'm not the only guy here doing robotics. We have 17 other faculty, and there's a lot of robotics companies in Austin, so we can give you a tour as well.
Awesome. That'd be great. Well, again, thank you very much, and thank you for tuning in to another episode of Trends with Benefits.